Hello everyone, welcome to our channel, and we have a new circuit here. This one is our new circuit. This is called a relay inverter logic gates, and this is the circuit diagram. We are on the control side and the load side of the relay. Terminal 1, 2, 3, 4, 5. At the control side we have a voltage supply of 6 volts, and in the load side we have this 12 volts. So we have the circuit here. We also have this push button. Also we have the LED power on indicator here, and also the LED load at the 12 volt supply. So in here, this is the 12 volt supply, and this one is 6 volt supply. This is the circuit. There's a relay LED, and that's our circuit here. So let us examine the current flow. We need to compute for the resistor to prevent the LED from burning out. Also here, resistor is needed to protect the LED. Since we have two power supply here, when you close the switch, all the LED power on is turning on. So we get this KBL here, and we have the voltage up across the resistor RB 4 volts and ohms law. We get a resistor value of 220 ohms for this. Where is that? Yeah, this one. Also KBL here. Voltage supply minus voltage of the resistor diode, and we get this value of resistor of 1 kilo ohms. So since this is a inverter gate, when you push the button here, LED turns up. That is an inverter logic gate using a relay. It has a truth table of no low signal, output is 1. Means there's no signal here, no output, 0. LED turns on, so the output is 1. When there's a signal here or high input, LED turns up. So this one is the symbol for inverter. Triangle with the circle or at the tip of an arrow. This is the layout, actual layout of the circuit. Unlike here, we have this one, our previous circuit. This is a relay buffer gate, logic gates. So this one is the relay buffer gate. So it has a truth table of low signal, 0, no output. When there's a high signal or high, there is an output here. And like here, it inverts. That's why they call it inverter. This is a buffer gate. This is an inverter gate. As you have seen here in our previous circuit, it has also two power supply. This is 6 volts power supply, and the other one is 12 volts. just like in the diagram here, 6 volts, 12 volts, and the LED is connected this way to the pin 5 of the relay. So normally there's no current flow, closed circuit here. That's why it is off. When you push the button here, current flows to the coil, inducing a voltage here, moving the contact to 5, making a closed circuit here because there's a voltage supply here. There's no electrical connection. Only the magnetic field is developed here, making the contact to move to the other terminal, making a closed circuit here in this buffer gate. While in our new circuit here, the connection is normally a closed circuit. Now the terminal is connected to pin number 4, and that makes it a relay inverter logic gate. Normally the LED is turned on because there's a closed circuit here. Once you push the button here, current flows into the coil, inducing a voltage, moving the contact into the terminal 5, making this an open circuit. Because the terminal moves to the terminal 5, there's no more circuit here. It will become open circuit. So that's why when you push it, LED turns off. That is the LED. This is one way of connecting a relay. This is a power on indicator. This one, just a power on indicator. Just to make sure that the circuit is on this LED here. We have the truth table here, layout. This one is also a buffer gate, with only one supply voltage here. Since this is our previous circuit, well, the LED here is connected into the terminal 5, just like a bridge here. When you push the button here, current flows here, push the button, current flows to the LED, move. Since the current flows here, using a voltage, producing a magnetic field, attracting the contact to move to terminal 5, making a closed circuit here. So LED turns on. There's two closed circuit here. Current flows into the coil, making a magnetic field, attracting 4 to 5, making a closed circuit here. Current flows here and also here at the same time. That's a relay buffer gate. The only difference is it has only one supply voltage here, only 6 volts. And this one, a relay circuit here, is a normal relay circuit. This is our previous circuit, just a normal relay circuit here. When you close the switch, current flows here because there's a magnetic field developed by the coil. When the current flows into the coil, moving the terminal to the terminal 5, make a closed circuit here and also a current flowing here. So that is a relay circuit. This one, as I've said, this is a buffer gate. Also buffer gate. This is a buffer gate also. Buffer gate, only one power supply. A buffer gate, only two power supply here. One power supply, two power supply, and this one is our inverter. It inverts the signal from LED is turning on, then when you push the button, turn off. Inverter. This one from LED turning off. LED is off. Push the button, LED turns on. That is the relay buffer gate. So we now come here to our new circuit. So this is a one way of connecting a relay. Just remember that the connection is this: 4, 3, the 2 is here, grounded, 1 to the push button. When I'm using a relay here, rated at 6 volts to the control side, and load side, it is capable of handling much bigger load. It could be a 220 volts at 10 ampere. Also a bulb, a regular electric bulb can also use instead of LED here, while I'm using LED here. So this is our circuit. Just make a difference between the two circuits here, the inverter and the buffer gate. So buffer gate is this. See the connection? Power supply here, LED resistor to the terminal 5. Here, those LEDs connected to terminal 4. Normally, it has a closed circuit here. That's why LED turns on. In here, there's no closed circuit here because the LED is connected to terminal 4. So LED turns off here unless you push a button here. So that's the difference between this relay inverter and relay buffer gate. Okay, thank you for watching. Bye.